In this video, we're going to learn some more skills that we need for graphing, like concavity and limits at infinity, and then we're going to do some curve sketching using these skills. All right, so let's just look at the first problem. In the first problem, we want to find where f of x, this curve, is concave up and concave down, and we also want to find inflection points. Inflection points occur when the curve changes from concave up to down or down to up. Well, concavity depends on the second derivative, the sign of the second derivative. All right, if f double prime is greater than 0, that means concave up. And if f double prime is less than 0, that means concave down. All right, so let's take the second derivative. Okay, we have to start by taking the first derivative, term by term. So here we have 4x cubed minus 24x squared plus 2 times 18, that's 36x. All right, now we're ready for the second derivative. So we have here, take term by term, the 4x cubed, the derivative is 12x squared. And here we have 2 times 24 minus 48x plus 36. Now we're going to do a plus minus analysis to see where this is positive and negative. All right, so first we have to see where it's 0, and we'll put those zeros on the number line. Let's factor out 12. And we have x squared minus 4x plus 3. Okay, again, we want to know where is this equal to 0. Okay, let's factor this, and we have x minus 3, x minus 1. So we see that f double prime is equal to 0 when x equals 3, and when x is equal to 1. So we're going to put these on the number line when we do our plus minus analysis. These are possible inflection points. Okay, so here we go. F double prime. It's good to write it next to the number line when you do the plus minus analysis. All right, so let's put 1 and 3, the zeros of f double prime, on the number line and start substituting in. Okay, if we substitute in a 4, which is in this interval, everything is positive. If we substitute in a 2, let's say, then we have this is negative and this is positive, so f double prime would be negative here. If we substitute in 0, both factors are negative, so f double prime would be positive. 2 negatives, that would be positive. Okay, so that tells us that f is concave up on this interval, concave down in between the 1 and the 3, and concave up on this interval. Furthermore, since the concavity changes when you pass through 1 and when you pass through 3, at x equal 1 and x equal 3, we have inflection points. So 1 comma f of 1, okay, it's important you substitute back into f, not into f prime. Okay, and another inflection point at 3 comma f of 1. Again, substitute back into the original into f. All right, sorry, this is 3 comma f of 3. Let me change that. Okay, so those would be the inflection points. Let's just figure out f of 1 and f of 3. We'll do that over here. Okay, so here's the calculation right here. F of 1 is equal to 11, and f of 3 is equal to 27, substituting back into the original, into f right here. Okay, so the inflection points are at 1 comma 11 and 3 comma 27. So those are inflection points. We have 2 inflection points, and here the curve is concave up, down, and up. Number 2 is really a pre-calculus question. We're not going to use derivatives here. We want to find x-intercepts, the y-intercept, and any vertical asymptotes of this function. All right, so let's remember that x-intercepts occur where the numerator is 0. So to find the x-intercept, we just write 3x minus 2 equals 0. So we get 3x equal 2. And just divide by 3, and we have x is equal to 2/3. All right. So that's our x-intercept. Now, vertical asymptotes occur where the denominator is 0. So let's first factor this. Just factor out an x, and we have x times x plus 5. Okay, so where is this 0? This is 0 when x equals 0 and when x is equal to negative 5. So x equals 0, x is equal to minus 5. Those are our vertical asymptotes. And now we just want the y-intercept. So for the y-intercept, we just sub in x equals 0, and we have y is equal to, if we sub 0, we have, okay, let me just write it out, 3 times 0 minus 2 over, actually we get a denominator of 0. So there is no y-intercept. In fact, x equals 0, which is the same as the y-intercept, is a vertical asymptote. The y-axis, okay, the y-axis is actually a vertical asymptote. All right, so let me just write that down. The y-axis is a vertical asymptote. That means the curve does not intersect the y-axis. The curve approaches the y-axis but never touches it. So no y-intercept here. In number 3, we're finding what we call end behavior. This is again pre-calculus because we're not using derivatives. That is the limit as x goes to infinity and as x goes to minus infinity. So let's start with A. So what we do is we say that the end behavior is really determined by the quotient of the highest power in the numerator divided by the highest power in the denominator. Okay, so as x goes to infinity, we'll just write it like this. Minus 3x to the 5th divided by 2x to the 5th. And we ignore the terms of lower degree. Just ignore those. This, which we reduce, this is equal to minus 3/2, is going to be the limit as x goes to infinity. And we'll actually get exactly the same thing as x goes to minus infinity. So when the end behavior is a finite number, like minus 3/2, that represents a horizontal asymptote. So this curve f of x has a horizontal asymptote at y equal negative 3/2. Okay, again, we're finding end behavior. So let's do what we did in the previous example. We'll say as x goes to infinity. And again, we're just looking at the highest degree terms. So that would be minus 4 x to the 7th divided by x to the 4th. Now reduce that. That's minus 4 x cubed. Well, as x goes to infinity, minus 4x cubed is going to go to negative infinity, negative because of this minus 4 over here. And as x goes to minus infinity, minus 4x cubed, well, the x cubed part is going to minus infinity, and then we have this minus 4 in front, so that's going to go to positive infinity. So that's our end behavior. And so there's no horizontal asymptote here. Here, basically, on the right, the curve is going down. So you can say it's going down on the right. On the right is x going to infinity. On the left, we have x going to minus infinity. Down on the right and plus infinity, that would be up on the left. Okay, let's look at C. So again, the same way we're going to say as x goes to infinity, and we're only looking at highest order here and here. Okay, so we have 3x to the 5th over 2x to the 6th. Okay, reduce that. That reduces to 3 over 2x. Okay, so we end up with an x in the denominator. So the denominator is getting very large, and this is going to 3 over something very large, so that goes to 0. And as x goes to negative infinity, we have the same situation. This goes to 3 over a negative number that's very large in magnitude, so again, this goes to 0. All right, finite number, so that means horizontal asymptote at x equals 0. Sorry, at y equals 0, which is the x-axis. Horizontal asymptote at y equals 0. That is, the x-axis is a horizontal asymptote.